Hey everybody, welcome to our second session of the first day. How's everybody doing so far? Oh, yes, good. So we're going to talk to you a little bit about digital twins today. And my name is Sarah Causey, and this is Andrew with me. We are co-founders of Implexus Lab. We are self-taught Unreal Engine developers, which I think is sort of awesome and the point of Epic Games and providing this platform for all of us. And we're going to sort of adult show and tell what we've built with the engine today, specifically for Argonne National Laboratory. So a little bit about what we're covering today, although this isn't necessarily in a strict order. We're going to talk a little bit about how we define digital twins. I know those terms are used so much in different industries in different ways, but I think it's important first to establish that baseline of how we define those two words. I'm getting feedback, so I'm going to stand a little further away from you. We're going to talk about the journey at Argonne National Laboratory, how they came, from CAD and nothing to where we are today in a digital twin in Unreal. Sort of the parts and pieces to that. Maybe you can learn something from that process if you haven't done it before. We're going to introduce the concept of data brokerage. So there is a company that we worked with as one of their primary beta testers, and they wanted to be with us here today, but they couldn't join. So we're going to cover some of that information for them. And then we're going to give a little bit of information of how we've made the digital twin immersive. All right.
So like Sarah said, my name is Andrew Heilman. I'd like to start off with who was involved in the project. Our goal for this project was to build a real-time digital twin for Argonne National Laboratory's Mechanisms Engineering Test Loop, or METL facility. We'll describe more about the facility later on, but the story has three main characters: Argonne, the end user in the case study; ourselves, the digital twin developers producing the final and still evolving product for Argonne, final, still working on it; Datasculpt as the Epic MegaGrant recipient, who plays a critical role in the way this twin was and continues to be developed. You might be wondering who we are. We are Implexus Lab, or simply Implexus. Implexus is Latin and means to embrace or entwine. Our goal in building digital twins is to entwine data and reality. Many of you might be familiar with platonic solids. The first four platonic solids represent fire, earth, air, and water. The fifth element commonly represents the dodecahedron is associated with the ether. Ether is the non-tangible, and in our case, that's the insight that is provided through layers of connected data over their various tangible forms. A digital twin. We're lucky enough to present early in the week, so hopefully you haven't seen too many definition slides, but let's talk a little bit about how we define these two words. When we say we're entwining data and reality at Implexus, that means a true digital twin begins with the marriage between real-time data and three-dimensional form, or a real-world object. The way in which we define digital twin is a digital twin is a virtual representation of real-world entities and processes that are synchronized at a specific frequency and fidelity, use real-time and historical data, and represents the past, present, and predicted futures. So Implexus is a member of the Digital Twin Consortium. The consortium is a global group of companies working to set standardization around that terminology and the quality of what constitutes digital twin. Our definition aligns with those efforts. The synchronizations between the physical and digital domains allows us to gain information to make decisions. What we're really after in a digital twin is gaining wisdom in a monitor and maintain cycle. We want to keep a human in the loop, meaning someone must interact with the digital twin in order for any changes to take place to the physical objects. After a strong foundation of a digital twin system is constructed, one that is secure, well-built from hardware to visualization, and provides wisdom from reliable and coherent data, then we can start to begin to look into the future and experience. One trend that we're starting to see early adopters pursue is that transition from monitor and maintain digital twin system to remote control. As we'll discuss later, this is something we're in the process of developing with Argonne currently. We are anticipating the prevalence of autonomously operated digital twins throughout the industry, in which case the twin will not only predicts and prescribes optimum performance, but implements the changes directly to the equipment. So talking about the varying levels of digital twins, we can provide descriptive, what happened, diagnostic, why did it happen, predictive, what will happen, prescriptive, how can we make it happen better, and autonomous, how can we make it happen better all on its own. So that gives us, hindsight, insight, and foresight. What you're seeing here, as mentioned before, we're members of the Digital Twin Consortium. You're seeing on the screen a resource developed inside that group with 6 different categories. We've got data service, integration, intelligence, user experience, management, and finally, trustworthiness. We like to use this with any new digital client to understand what their needs are. And now we're going to spend a little bit of time on the data services group, the side on the left in blue.
All right, stick with us because this is highly technical, but please save your questions. We'd love to hear them at the end. And again, we're representing this team today. Jonathan would love to have been here from Scotland, but he's not. So we'll do our best to replicate that for y'all. All right, so you've heard everything we've talked about what a digital twin is. Say you're ready to go, you want to build a data-driven project. Maybe it's for a manufacturing facility like we're discussing today, or for vehicle HMI, or scientific data visualization. You'll likely have data out there in the world somewhere that you want to use. You may have a 3D model or a scene. Specifically, if you're building an AEC project, do we have architecture, engineering, and construction people in here? Yeah, cool. So that's the industry we come from, by the way. So you probably have some sort of model, and maybe in an Autodesk product or something like that. And you need to create a runtime application to do this. So you need a game editor, a real-time visualization engine, and a real-time visualization engine. We all know Unreal's the best one, so that's obviously what you're going to go with. But how do you bring it all together? There are many difficulties building data-driven projects that can be very hard, especially if you've never done it before. So let's outline some problems. Problem 1. You need to somehow connect all of that data to an engine reliably, something you can, it never breaks, that connection. This will probably entail C++ or blueprints, and maybe understanding server and API code and ONS file management. Problem 2, now you need to expose that data to drive properties or behaviors inside of Unreal, and again, traditionally C++ or blueprints. Problem 3, you probably need a way for your users to interact with the scene. That's the whole goal of the digital twin, such as to control data playback, query certain points in time. Maybe you have an intricate user interface. So this is where Datasculpt comes into play. This is a tool that's really intended to lower the barrier of entry to bringing data streams into Unreal. You can use it for digital twins, data visualization, human-machine interfaces, and it's really a very useful and easy to use tool. So the reason we're introducing this to you today is because we don't want to be the only ones playing in the digital twin world. We want everybody to go there because we think it's the future. So if this tool helps Unreal developers get there faster, let's go there. All right, so these are the solutions to the problems. For the data connection problem, Datasculpt provides a no-code data wizard, which allows you to connect Unreal to external data sources. Maybe that's log files or APIs. For the problem of making objects data-driven, Datasculpt provides a no-code visual drag and drop, and it's literally a drag and drop. You're going to see it here in a minute, that you can then use to apply behaviors to it. You don't even have to go into the blueprint if you're uncomfortable with that. For the problem of creating a user interface, Datasculpt provides a UI toolkit. This creates UI elements such as timelines and labels and ways to visualize and play with the data. And this is all baseline. You can obviously hop into the blueprint and edit and customize anything from there. Just gets you going. Okay, the platform is delivered in 2 parts. The DS Studio provides all the editor functionality, and it's wrapped into a plugin. That's what you're seeing on the left. And then the DS Engine, and so that's embedded into the packaged application, provides the functionality for creating and managing data connections securely. So we're talking about a national lab. Security is like the word of the day. We'll talk a little bit more about that in a second. The DS Studio Data Wizard allows you to add files or API data directly in. This is kind of what the interface looks like. Within each source, the individual data streams are exposed, right? So that you can actually see in that second image the ways you can grab the individual components in your data arrays and drag them and drop them into an interface, decide what you want to do with them. You can import CSV or JSON files and embed them into the project. And the API connector allows connection to REST APIs. So that's what we did for Argonne. There's also an early beta of a DS Cloud. We're not going to talk about that today, but if you have any cloud-based data streams you're trying to bring in, that is something they are testing and developing as we speak. The API connector allows embedding of dynamic parameters. We're also going to talk about that. That can be accessed and changed at runtime, which allows the users to change date, or range, or location, or even weather, if you want to bring that in. Okay, this is a video that's going to show an example of the DS Data Wizard. So you can bring that CSV in just a few seconds, and this will help you to see what it looks like, how you expose all those individual data points. And then you drag and drop them onto the screen. Let's talk about that. The DS Data Canvas is, again, a visual no-code interface for building data-driven behaviors. I'll just say it again to reiterate it. They're trying to make this easy so all of us can bring data in and start to provide value to whatever client you're working for. So the canvas allows dragging and dropping of data streams and behaviors into components in order to build flows. So you're attaching them to meshes or actors inside Unreal. The behavior library is a library of building blocks. It's starting, it's getting you going. There's certain functionality in here like the ability to translate, rotate, and scale objects in various ways. Maybe you want to move a vehicle around an environment based on the data location coming through. The ability to make objects change color based on data. The ability to create multi-sensor volumetric heat maps, which is what we did. I need to scroll this down a little bit. The ability to change material properties based on data. So maybe you're trying to alter opacity or roughness or emissivity of a custom parameter of custom material. The ability to change the visibility of objects. Let me come back in here. Within and out of animations based on curves, color curves. The ability to translate, rotate, and scale textures. Maybe you're trying to animate a conveyor belt or sort of a turbine based on a certain speed of data that's coming in. These are the sort of toolkit of behaviors you can begin with. Furthermore, the DS Canvas is now integrated with blueprints. So blueprint variables can be connected to data streams. We are going to show you how we did that as well. Via this drag and drop, it opens up all blueprints to be made data-driven directly with Datasculpt's UI. Without the need to enter the blueprint editor to make changes. Datasculpt can be used to set up data flows to drive most types of assets, such as Niagara particle effects, skeletal meshes, physics simulation inputs, and UMG widgets. Datasculpt also is integrated with CCM. Anybody using CCM out there for GIS? Yeah, awesome. Well, it's probably still CCM, but they did just get bought, so I'm very curious to see what happens with Bentley. So this allows the use of Datasculpt to translate behaviors on CCM globe anchor. So if you're trying to bring in real latitude and longitude and elevation of elements in the world, you can bring them in through this interface. All right, here's an example of the DS Canvas to create a data-driven jet engine. Again, it's just happening in seconds, where the turbine is turned using the RPM rotation behavior, which sets the rotation at a regular per minute rate. And that's based on whatever input value is coming in from your data stream. Here's an example of building a heat map on the turbine that's based on a temperature sensor data that's similar to what we're going to show you at Argonne. So the heat map supports theoretically an unlimited number of sensors, limited of course by the processing power of your machine. The sensors are automatically created as components, can be moved manually into position, and as they're being moved here, they can be data-driven through translate behaviors and positional data. One key feature, I think it's going to show you here in a second, is those data transform nodes. Yeah, right there. This node is created within every flow and allows various processes to be carried out on the data before it enters the behavior. So in this case, you can set a range, say 0 to 200 degrees Celsius. And the range map, from 0 to 1, allows the heat map gradient to, as you're seeing here displayed, to display appropriately across the mesh. When played, we can see the combustion chamber heating up to a much higher temperature than the intake compressor. So again, this is highly technical. I hope you're still with me. We will share how this is applied to our case study. A couple more things. Go ahead, Andrew.
A powerful feature of Datasculpt is the dynamic array spawner. So if you have an array of data objects and an object which you want to use as a template to be instanced from, with each instance driven by a different data object in that array, you can use the array spawner behavior, and this allows you to generate instance objects from a data object array. In this example, we're using cesium as the substrate, and we're going to use a live air traffic data API from this area, which is Edinburgh Airport. So the array spawner behavior is used to create a dynamic array of data-driven objects. And then once the data array that is sent from the API is plugged in, and each sub-object's unique identifier is added, a template object can then be selected. In this case, that's a commercial aircraft model available on the Unreal Marketplace or Fab. The components of the commercial aircraft becomes visible in the Datasculpt canvas, allowing behaviors and data streams to be added. Translate behavior is added, and the cesium globe anchor, allowing that latitude and longitude and elevation streams from the API to be plugged in. After this, when played, each aircraft is instanced, and the correct data is used to position it. These connections are maintained and updated for each new data point coming in from the API, so the scene is constantly updated in real time. The Datasculpt UI kit automates key user interface elements to allow each addition of user interactivity with the data. Firstly, automatic time controls can be created. These are composed of several features. They're automatic playback controls, play, pause, fast forward, reverse, skip, and various others. There's basic and advanced options and customizable settings. There's an automatic and dynamic timeline which scales based on the data and the time range. This can be dragged by the users for a time scrub. The user can set time interpolation globally or on a per behavior basis to allow smoother playback. And the actual number of interpolation steps is customizable by the user. When using a live stream API, the data received is cached locally and builds up a timeline dynamically, which the user can replay up to the current data. Secondly, 3D labeling is possible using the label behavior. Once attached to an actor and with a data stream plugged in, the user is able to toggle labeling in world, showing the data dynamically plus a custom description and units of measurement. Can also control aspects of the layout, such as font size, position, and numerical rounding. It is also possible when using the heat map to create point-based data interpolation, where the user can click on any point on the heat map surface and view an interpolated value from that data source. The label can be set to always show, or only on a click, or mouse over, however you want to have the fixed orientation, face the camera, what have you. Further, to do this, an outline around that object can be created simultaneously to give a better visualization feedback to the user of what has been selected. Color, thickness, all those things are customizable. So finally, the label also allows the creation of dynamic HUD widgets in the UMG. The user can select a UMG widget, and this will appear in the hierarchy in the Datasculpt canvas. The user can then plug in data streams directly to any variables in the widget. This works with the array spawner and allows the creation of complex HUD labels, which can either appear one at a time when an object is clicked or stack up as more objects are clicked and allow comparison. There was a need for an agnostic method of capturing the properties of data-driven scene to create portability and allow open flow around the real-time 3D ecosystem. So the DDOD, or data-driven object descriptor, does this by extracting all Datasculpt functionality for scene into a portable descriptor package, including data sources, behaviors, and data transforms, excuse me. The DDOD can be used to move whole Datasculpt scenes between projects or maps. It can also be used as a standalone with USD files to create complete tool agnostic file format for data-driven scenes. While utility is limited to the use within Unreal currently, the roadmap does plan to expand to usage beyond the wider, in the wider ecosystem very soon. Some more advanced features include being able to use many Datasculpt features directly in blueprints via dedicated Datasculpt nodes, including being able to access data streams and control the timeline. There are several advanced features currently in beta, including the use of Datasculpt via C++ with a library of Datasculpt functions to accelerate coding of data-driven applications. It's also possible to create custom behaviors based on your own blueprints and add these to the Datasculpt behavior library for repeatable use, including creating custom icons that appear in the Datasculpt library. Finally, it's also possible to create custom data transforms, which will be available directly in the data process node for repeatable use. For example, if you require particular mathematical processes applied to the incoming data, that's all available in that node.
Okay, so thank you for hanging in there with us and all that technical stuff. I hope that inspires you maybe a little bit, that you can get in here and start working with this now. If you're interested in using the tool, it is in early release, and the Datasculpt Cloud is in beta, and they want more people to work with, not just Andrew and I. So please feel free to reach out. I hope we did Jonathan justice. But now we get to our side of the story, which I think is quite exciting, which is how we applied this to Argonne National Laboratory. So let's talk a little bit about Argonne's history and what Argonne is. So Argonne National Laboratory is actually the first national laboratory in the US. It's about 30 miles southwest of Chicago, and its campus is pictured there on the right. So the roots are in nuclear energy. Who saw Oppenheimer? Yeah, great movie. So that's actually, Los Alamos was not the first lab. The University of Chicago was very involved in the Manhattan Project, and Argonne came out of that work. So although they do a lot of nuclear work there, they have one of the most diverse research portfolios across all 17 labs. If you want to nerd out with me here for a second, in the lower left-hand corner is that ring there is the synchrotron, which is an advanced photon source. So it produces some of the world's brightest X-rays for scientific research and discovery. And the building right above that is the Mathematical and Computing Theory and Sciences building, which houses Aurora. Y'all have heard of that, yeah? Yes. So it just broke the supercomputer exascale computing boundary last year. So very, very cool. I got to see it. It's massive. It's crazy. I'm not going to go into much detail about what's happening there because I don't know, but I think it's important to highlight the future vision of nuclear energy, because what they're looking for is AI-assisted reactor systems. So it's important to understand that the digital twin is offering them steps to get to that inevitable future. So earlier, Andrew showed you the capabilities periodic table. This is, oh man, the color's a little washed out. This is Argonne's. So anything sort of gray is something they're not prioritizing right now. But the data services are quite important. And for us, the UX, the green on the right, how are we using gaming engines? What sort of immersive experiences are they after? It's actually really interesting to see where they're going with that. So let's start with how the loop works. I, as an adult, would like to add to the adulting suggestion box more opportunities for Bring Your Friend to Work Day, because I had a lot of fun learning about this industry when I got to go. The image on the right, I want to stick in your brain for a little while for the rest of our time together. This is what the loop looks like and feels like in real life. So the picture on the top left, this is a liquid metal nuclear loop, okay? Usually it's water. I don't know how much y'all know about nuclear. So when it's cold and hardened, this is sodium. It looks like that picture on the top left. But in order to be used in a reactor, it has to be heated to extreme temperatures. We're talking 650 degrees Celsius. So as you can imagine, with humans in here, everything is shrouded in insulation. You can't anywhere get close to touching any of these elements. And there are wires, over 1,000 sensors in this lab, testing everything. All of those wires go to an on-site data center And whatever information is captured there is coming to this this control room or command center. And traditionally they have HMIs that are diagrammatic, maybe 2D plans, elevations, line charts, bar graphs, which are providing them a lot of insight. For those of you in AEC, think about like a BMS system. There's nothing wrong with that. It's providing them a lot of insight. But can the digital twin collect it all together, give you deeper insight or a quicker way to see what's going on with the health of this lab? Now we get to the fun part where we brought it into Unreal.
So the components used in this loop, from the images you saw Sarah share, obviously you can't buy those off the shelf. So these are being designed and developed in-house, which means there's no content out there to represent the form. But luckily, the designers and engineers at Argonne used Autodesk Inventor to design and build the loop components. And the facility itself, or the building shell, was also modeled in Autodesk Revit. In addition to the BIM work and Inventor files, which are relatively close to reality, they also used reality capture technology to document the as-built environment. I've got Matterport on the left. And then I believe this is Autodesk Recap on the right. I'm sure reality capture from Unreal would have done a better job. It's important to also note that before the digital twin work began, the lab was experimenting with extended reality in a couple different use cases. Got an example here of some early HoloLens experiments used to show what was occurring behind the scenes in a test vessel. So just with a couple geo-trackers, they had the obvious problems with AR, with drift, and issues that pushed them closer towards the idea of a true digital twin. Finally, as they began pursuing the idea of developing a virtual command center to control the nuclear facility remotely, the need for a digital twin arose, and the primary motivation behind a virtual command center is due to the lack of on-site technical expertise. So how the twin works, how we got there. Like I mentioned before, we started with BIM in the form of Autodesk Revit and Inventor. Now these are both solid modelers, and the transition to mesh can be quite messy. I'm sure many of you are familiar with that. Using Revit, Datasmith export would have resulted in way too many objects for the later application of Datasculpt. But we did utilize Datasmith for the less complex building model. So that Revit model was quick and easy to collapse by material, ran it through Twinmotion, put a couple new textures on it, import directly to Unreal, saved a lot of time. But for the actual reactor components, we wanted to be able to grab pipe segments between two sensor locations. So unfortunately, that became a manual joining process with plenty of mesh cleanup along the way, plenty of mesh cleanup. But during that cleanup in Blender, we reduced the object count from 5,000 plus objects, like elbows, pipes, bolts, insulation, everything. Connections to around 220 zones, matching labeled 2D diagrams from Argonne. During that process, we also reduced face count significantly. This made it possible to assign sensor data to each endpoint of the now labeled actor inside Unreal.
All right, once the mesh was broken out across those 220 censored zones, we began assigning data to each endpoint of the actor, like you're seeing the left and right sides here. You see those little black spheres are the sensor locations. We actually named each actor in Unreal the sensor number so that we didn't get confused across these large quantities of sensors, and we're able to more easily associate the data point with the mesh. So our data is coming through REST API calls. I think I mentioned that earlier. Once married together, once the data and the mesh is married together, we don't ever want that connection to change or get lost. That marriage needs to be permanent. And I say that because we learned the lesson the hard way. If you want to start developing digital twins like this for your clients, make sure you have really strong conversations at the beginning about their data coherence and their data structure, because you don't want them to change it. At one point through this project, Argonne actually changed their web service provider. So all of the data, the construction of the array changed. There was a new layer added. So if you're following along with me, that meant I had to go back and remap all of these, which was not fun. That's okay, we could do it. All right, I can't show you the real data for obvious reasons, but I'd like to display a little bit about how we controlled variables inside this. So the censored actors in Unreal interact with Argonne's data using a REST API, right? I should mention here that working with the government, there's a lot of protocol and security around this. So we actually have Argonne email addresses as if we work there, Argonne accounts, and we tap into their VPN. So we don't own their data, it's all theirs, on-prem, it's not in the cloud, and we tap in directly. I honestly believe that that's probably the safest way to do this. So our REST API connection through Datasculpt is done via HTTP requests, where we've embedded variables, which you're seeing in the red text here, directly into the request URL. So changing specific parts of the URL dynamically, and we can actually grab these variables in our blueprints. The digital twin can request different sets of information, and it updates to the appropriate elements, time, historic values, whatever we're looking for here. And it's retrieved and displayed properly. Does that make sense? Okay, cool. I was worried. Okay, now you get to watch the fun video. We wanted to show you this live, but we can't. So this is a recording of the editor mode in PC. So here's the facility. Again, outside the context came from Revit. This looks interesting, but I left in here on purpose because if you saw the previous presentation, you know, or if you've worked with reality capture before, you really have to understand the level of accuracy and how quickly from point to point of the scan, you know, how closely you need those overlaps so that the scan is good. So I leave that in there on purpose to show you what bad looks like. So this is our absolute temperatures level. We did build in some ability to turn off building context, so you can just view the loop as a whole. Think back about that picture where it's all shrouded in insulation and wires. They couldn't view their loop like this until we built it in here. There's collision spheres with 3D text, and that's all you're doing is you're getting closer to the sensor and it's popping up that information so they're able to orient themselves. And these are those 3D labels we talked about. So that's showing, I think the frequency we set was 1 second. So that's showing the data every 1 second. The temperature filter here just allows them to just view the loop at certain points in time, or certain temperature ranges. So if they want to focus in on the high end or the low end, this helps them view that. These are all requests that came from Argonne. Same thing for relative temperatures. It's just different color display here. So again, you collide into those spheres and you're able to see the information and locate where you are. And same thing with the temperature filter here. I am going to talk briefly about custom user definition level. They wanted to be able to input a certain query of historical times. You put your date, your time, your temperature range, and it will actually populate that for you. So there's a timeliner on the bottom. I'm not sure how clearly you can see that. This is just 1 minute in January that we asked, and it will display, and you push the play button, and it'll show you what happened during that 1 minute of time. So if there's an anomaly going on in the loop and you want to understand and go back and see what could have happened here and what was affected, they can pretty quickly and easily do that. Talk too fast. All right, and then most recently we trained a chatbot on information about the loop, so they can not only query time and date, but information specifically, or in this case, what's the specification? I'm a front-end technician and I need to clean the loop or do something with it. You can query that information and experience it that way. And just to reiterate something we said earlier, the talent shortage or the expertise shortage is really what they're looking for here. So how can I have a guy or gal in Minnesota controlling this facility remotely? So we actually built that game in both PC and VR builds. The headset we used was the MetaQuest Pro. That seems to be working for them. I mean, you saw earlier they're using a variety of different headsets. So really, you know, like we said, they started with this physical lab, hard to visualize. They were getting value from their HMI. The cases are 2D plans, elevations, graphs. There is value there, but they really see the ultimate benefit here in that future vision of AI assisted by moving into 3D, moving into a gaming engine, and showing that information in a digital twin. And like I said, lastly, they're able to create an immersive experience, and they seem to be really liking it. And it's an ongoing relationship. We started working with them in 2020. And we're just looking forward to what's next. We're going to be focusing on some training simulations, which we can use the exact same model we created and just continue that relationship and expand upon it over time. So this is what we talked about and some extra other things. We would love to open time here as much as we can. We can't answer too many questions about Datasculpt, but we'd love to answer any questions that you have with our remaining time. Cool. All right. Well, we're here all week if you have any other questions. And thanks for joining us today. We appreciate it.